Hello everyone, I'm Masaki Matsunaga, Corporate Officer, Director of Plan Approval and Technical Solution Division, ClassNK Tokyo. I would like to express my sincere appreciation to everyone for participating in this event. It is an honor to host this panel discussion today. The topic of this panel discussion is designing ships of the future technology to ensure decarbonization, ship and society. Decarbonization is the most challenging issue our maritime industry is facing. I believe today's topic, future ship design, is one of the key elements for establishing a supply chain for future decarbonization. Today, we have three distinguished panelists from shipyards and a trading company. We'd like to hear about the efforts of each company, both independently and through partnership on this topic. First of all, I would like to welcome all panelists and ask you to briefly introduce yourself. I'd like to ask Mr. Motoi first.
Hi, hello everyone. My name is Tatsuya Motoi, Deputy General Manager of Ship and Offshore Business Division, Kawasaki Heavy Industries. I am naval architect, and I have been in charge of structural design of LNG and LPG carriers for many years. Now, we Kawasaki make efforts to develop hydrogen carrier. I hope today's discussion is helpful to you. Thank you.
Thank you. Mr. Akamatsu, please.
Hello, everybody, and thank you very much for today's opportunity from Capital Link and the ClassNK. And I'm Akamatsu from Itochu Corporation, General Manager of Green Innovation Business Unit. And nowadays, we are focusing on ammonia as a maritime fuel to challenge a zero emission project with various partners. Today, we'd like to share what we are doing now. Thank you.
Thanks. Mr. Ueda, please.
Hello, my name is Shin Ueda, and from Mitsubishi Shipbuilding. I'm the Director of Ship and Ocean Engineering Department. Mitsubishi Shipbuilding is very keen about the future solution of marine applications, and especially environmental solutions. So I'm very glad to join this forum, and thank you very much for today.
Thank you. Thank you, everyone. Now, I would like to proceed with a discussion on the topic. But first, Mr. Motoi, I think your company is approaching decarbonization with quite advanced technology, especially in the hydrogen supply chain. I'd like you to share it with us first. Mr. Motoi, please.
Thank you, Matsunaga-san, for your kind introduction. Today, I'm going to talk about the development of a liquefied hydrogen carrier. I'd like to start with the concept of the international liquefied hydrogen supply chain. As you know, hydrogen can be produced from various sources, including fossil fuel and renewable energy, and may enhance the energy security of Japan. We are discussing with many stakeholders to realize hydrogen supply chain. For the perspective of cost and energy security, we are focusing on Australia due to its abundant resources and the safer voyage route to and from Japan. This slide shows a summary of the international hydrogen supply chain that Kawasaki is aiming. The hydrogen energy supply chain consists of production, transport, storage, and utilization. Renewable energy would be the most prospective resource for hydrogen production. Until the moment when the hydrogen supply foundation will be ready, we utilize the abundant fossil fuel like brown coal in Australia and CO2 capture and storage technology to produce hydrogen. The electric carrier is one of the key factors that implement the mass transportation of hydrogen. The purpose of the pilot project is to demonstrate hydrogen production at Rattlef Valley in Australia, liquefaction and storage at Hastings Port, marine transportation from Australia to Japan, and unloading at Kobe Terminal in Japan. The pilot project is divided in 2 portions and is being promoted by 2 organizations, Hystra and HA, respectively. Hystra is in charge of the portion indicated with blue rectangles, including production from Victorian coal, marine transportation by L2 carrier, and unloading at the terminal in Japan, all of which had been met with technical hurdles. On the other hand, HA is in charge of the portion indicated with orange rectangle, including refining, land transport, liquefaction, and exporting from Australian terminal. This is the world's first L2 carrier that we Kawasaki built in Kobe Shipyard and delivered in 2021. The vessel is named Suiso Frontier. This vessel is equipped with a vacuum-insulated cargo tank of 1,250 cubic meters. Cargo piping system is also vacuum insulated to minimize heat ingress during loading and unloading. The temperature of liquefied hydrogen is -253 degrees Celsius. Therefore, extremely high level of installation system is required. Then, vacuum insulated double shell structure is applied for cargo containment system. This cargo tank is designed to accumulate boil-off gas during the voyage under full loaded condition. Regarding the material, the inner vessel is made of stainless steel, and the saddle support of the inner vessel is made of GFRP, which have excellent thermal insulation properties and strengths. After the completion of L2 carrier and L2 terminal, the demonstration was conducted in 2 phases. In the first phase, the tests for loading and unloading operation were carried out. In these tests, performance of cargo equipment were also verified, practically using liquefied hydrogen. Following these tests, the demonstration of full load trial voyage in Japanese coastal waters was conducted in October 2021. In the second phase of demonstration, long-haul transportation with 9,000 kilometers distance between Hastings, Australia, and Itochu, Kobe, Japan was conducted. Through a series of these demonstration tests, all aspects, including safety and technology used in long-haul transportation and cargo handling, were successfully verified. The last part of this presentation is our actions for commercialization. This slide shows recent hydrogen business project under consideration and investigation in the world. As hydrogen can be produced from various resources and can be transported in large amount with lower cost, many companies in the world are promoting feasibility studies on hydrogen businesses. We Kawasaki aim to contribute to early achievement of decarbonization through this project as their partner. As you can see, Kawasaki has achieved important milestones and is steadily moving toward the deployment of a full hydrogen supply chain from production to utilization. The next major step is commercialization. With the aim of achieving full-scale commercialization in the 2030s, we started development of scaling up technology from 2019 and start a commercial scale demonstration in the mid-2020s. Our partners are also developing other essential equipment for large-scale supply chain. This is a graphic image of large-scale LH2 carrier under development. This vessel can transport about 160,000 cubic meters of LH2. 4 of 40,000 cubic meter cargo tanks are to be installed. The propulsion system is designed to effectively utilize boil-off gas as fuel, thus contributing to reduce the CO2 emission from transportation. This April, Kawasaki obtained approval in principle from ClassNK for its cargo containment system, cargo handling system, and hydrogen fuels propulsion system. The AIP was issued by ClassNK following examination to confirm that the vessel satisfied the IGC code and the IMO interim recommendations, ClassNK's regulations and guidelines. In conclusion, I'd like to emphasize the importance of the CO2-free hydrogen supply chain for accomplishing decarbonization. Hydrogen from fossil resources such as natural gas, coal, and so on, linked with CO2 capture and storage technology, will realize the best energy supply chain. This contributes to stable energy supply and security. Hydrogen utilization emits no CO2. Thus, hydrogen is expected to play an essential role in the decarbonization. Wide use of hydrogen brings industrial and economic growth. Lastly, hydrogen production started from fossil fuel will be shifted to the renewable energies in the future. We believe that this will achieve a sustainable energy society. This concludes my presentation. Thank you very much for your kind attention. Thank you.
Thank you. Thank you for sharing a quite interesting topic, Mr. Motoi. Do the panelists have any question about this topic? How about Mr. Akamatsu?
Hello. Yes. Thank you very much, Motoi-san, about your challenge. And so we are very much happy to hear that the first technical demonstration was carried out successfully. And now the stage of scale up. And our question is, what will be a challenge for scale up of liquid hydrogen project?
Thank you, Akamatsu-san. Well, as cargo tank volume increase, vacuum insulated double shell structure, which a pilot vessel is applied, is not practical. Then we are developing a new cargo tank systems. And we also plan to utilize boil-off gas as fuel of propulsion systems. That's a challenge. Thank you.
Thank you. How about Mr. Ueda? Do you have any question to him?
Yes. Thank you, Motoi-san, for your good explanation about the hydrogen, liquefied hydrogen ship. And you have many experience for the building the LNG carrier. And I would like to ask you about what do you think of the main differences between the hydrogen carriers and LNG carriers? Could you share some points?
Okay, thank you, Ueda-san. The point is difference between the physical properties of hydrogen and LNG. Liquefied hydrogen is 10 times evaporable than LNG. This means insulation thickness could be 10 times thicker than LNG carrier, but not practical. Then the insulation system must be newly developed for electric carrier. This is a major challenge. And liquefied temperature of hydrogen is minus 253 degrees Celsius, which is 19 degrees lower than LNG. So as thermal shrinkage of cargo tank structure is larger than that of LNG carrier, then the care should be taken for structure design. That is the major difference.
Thank you.
Okay, thank you for your explanation, Mr. Motoi. Then I'd like to move to second topic. Mr. Akamatsu, I think your company is playing an important role in the ammonia supply chain. I would like you to share your project with us. Mr. Akamatsu, please.
Okay, thank you very much. Can you see the screen? Oops.
Yes.
It's okay?
Okay, yes. Okay, so thank you very much again. So we, Itochu Corporation, is one of the trading house in Japan. And so we are not a shipyard and we are not a shipping company. But as the approach from a trading company's point of view, we try to contribute zero emission shipping nowadays with ammonia fuel. Maybe. Okay. And so today we have a lot of potential fuel. Of course, today conventional fuel, LNG, methanol, biofuel, already we can say existing fuel. But in order for us to achieve zero emission, we should consider something different, such as hydrogen-based fuel. So of course, liquid hydrogen is one of the potential fuel in the future. But from the view of a trading house, we are not a technical providers. So maybe we should wait for like a hydrogen engine project when it is ready. Then we are now focusing on ammonia because simply the technology is almost ready. So now is the time to make a business development with like a trading company like us. And if we say the current status of ammonia vessel, so first we have two issues: engine development and safety guideline. So engine development, of course, various manufacturers are working for development of ammonia engine. But as far as we understand, for example, like MAN Energy Solutions, they will carry out engine test from second half of this year. So if the result of engine test is positive, then we assume engine will be ready. And the safety guideline, we have two guidelines. One is for ammonia fuel vessel, and the second is for bunkering. So first guideline for ammonia fuel vessel, I think like ClassNK and other classification societies already issued the guideline. And now IMO, they have a discussion about the international guideline. So I believe that is a matter of time. But at the same time, we need to have a guideline for ammonia bunkering. So which should be determined by local port authorities at each countries. So later on, we will explain about our strategy, but we focus on Singapore as a pilot case. And the Singapore Maritime Port Authorities, they are now under development of a bunkering guideline. So I think that will be also a matter of time, and maybe sometimes end of this year or early next year, which seems to be ready. And then if engine and safety guideline is ready, then next question is economics. Of course, now we do understand that the IMO, they have a discussion about the MBA, and the Japanese government proposed their own ideas. And we are very much focusing on what would be the discussions at the IMO. And so, because technically it's almost ready, then we trading company try to develop the business side. So we intend to develop all categories at the same time, so-called integrated project. Because always, if we talk about alternative fuel, we have a story of a chicken or egg. To avoid a chicken or egg story, we intend to develop together with the partners in the various categories. So shipbuilding side, we are working with the Nihon Shipyard, Mitsubishi, ClassNK to develop the vessel with ammonia engine, and also which should be owned by Itochu and the shipping company partners and charter to end user. But in order for us to encourage end user to take it, so we have to prepare the bunkering. So we focus on Singapore as a pilot case and working with the parties here, like Pavilion, Total Energy, MOL, Vopak. And also production side, if we introduced ammonia as a marine fuel, we have to say we need to have new productions. So we have to develop with a potential partner to produce ammonia for marine use. So our idea is to develop 4 categories at the same time together. And our target for pilot project is to deliver first vessel with ammonia engine sometimes at the first quarter of 2026, assuming that engine is ready in 2024. And based on our marketing, we for the time being, we decided to focus on 200K deadweight type bulk carriers as a pilot project, mainly to carry iron ore. So means our end user would be mining company or steel manufacturers. And then thereafter, we intend to expand other vessels like container carriers or tankers or some other bulk carriers. And as to ammonia fuel procurement, for the time being in the market, we have only gray ammonia. But from a shipper's point of view, they are not interested in the gray. So we intend to supply blue or green. And if we talk about the global network of ammonia bunkering, as we pointed out, we focus on Singapore as a pilot case. But if we try to expand various vessel type, so we have to prepare a global network. So we try to establish the bunkering station like Europe, like Middle East, Japan, South Africa, Panama, or many other places, maybe with partners. So that is our ideas. And based on this project, for pilot project, so we obtained support from Green Innovation Fund from the Japanese government. So based on this support, we are now trying to develop the first project together with partners. Means Nihon Shipyard, Mitsubishi, and the shipping side, Kawasaki, Shin, Line, and NS United Kind. So we are now under process to commercialize the first vessel together. And coming back to the bunkering side, so in Singapore, we are working with the partners. And so early this year, we obtained AIP from Singapore Shipyard Sembcorp together. And then we do understand what will be an issue for ammonia bunkering in Singapore, then intend to discuss those pending issues with like port authorities. So to accelerate our discussion in Singapore, our consortium, 6 parties, we executed the MOU with Singapore MPA last April at the time of the Singapore Maritime Week to discuss further about the ammonia bunkering in Singapore. At the same time, Itochu, we are trying to develop the joint study frameworks in the market, especially for shippers, because many of the shippers, it is a challenge for them to use ammonia as a fuel. So they requested us to prepare kind of joint learning structure. So we organized first joint study framework, mainly with shippers and classification society, including ClassNK. And we carried out something around 30 sessions to talk about 4 common issues: safety for ammonia fuel vessel and bunkering, ammonia fuel specification, and net CO2 emission of ammonia productions. But then we realized in order for us to discuss about the safety for ammonia bunkering, so we need to involve port authorities. So early this year, we decided to establish second framework for joint study with mainly port authorities. So that is the second joint study framework. And nowadays we are doing a joint session with two joint study framework, and invited several experts to make a presentation to share their knowledge. But nowadays, we also established a working group for key factors related to ammonia safety bunkering, mainly with port authorities. And we are now discussing what would be the direction of ammonia safety bunkering. And we come back to our pilot project. So we intend to deliver the first vessel in the first quarter of 2026. So in that sense, we need to achieve FID sometimes early next year, which is very challenging because still, we have to wait for engine test. But that is our target, and we try to work together with various partners to achieve this target, not only for ammonia fuel vessel, but also the bunkering side. And the challenge from now, we have to say, technical and commercial. So technical, we think that the design development should be done by the shipyard, but of course, which should be done in parallel of establishment of international guideline and bunkering guideline at the local port. Therefore, how we can make an interface among rules, guidelines, and ship designs together. So that is one of the challenge. In the commercial, of course, except like a price, we have to consider what kind of trading system we established for ammonia fuel, especially like scope of CO2 emission. Nowadays, people are talking about life cycle assessment and how we should evaluate life cycle assessment and how we should get the certificate and how we should trade it. So that is maybe the challenge. And also the price mechanism. We don't have any ammonia fuel price today. It's only the price for ammonia for fertilizer business. So how we consider price index for ammonia fuel and how we should evaluate CO2 premium in case of blue or green ammonia, if our price index is based on gray ammonia. So those issues we have to discuss with various stakeholders, not only shippers, ship owners, bunkering suppliers, producers, many of them. So how we can make this kind of supply chain, I think that is also next challenge. So that is all from my side. Thank you very much.
Thank you. Thank you for your explanation. This is very interesting information. So, Mr. Motoi, do you have any question to him?
Well, thank you, Akamatsu, for your kind presentation. I think ammonia is one of the alternatives for future energy as well as hydrogen. So my question is about supply chain for ammonia as marine fuel. How about the future prospect to expand ammonia utilization?
Okay, thank you very much. So I think we have to consider vessel shipping route and bunkering position and the production side. What would be most suitable supply chain for each? Therefore, if we talk about like a Singapore bunkering for some shipping route, then of course we have to find the proper production nearby, like from somewhere in the Far East countries like Malaysia, Indonesia, or Australia, or maybe Middle East. Well, I mean, if we prepare the bunkering station in Europe, then maybe we have to prepare supply chain from like somewhere in Europe or Middle East or maybe Africa. Therefore, maybe depending upon the shipping route, cargoes, then decide where is the proper location of the bunkering site. Then we have to find what is the best ammonia for this bunkering. So it's very complicated, but we should start somewhere.
Thank you.
Thank
And
you.
the situation is the same as hydrogen.
Yeah, we agree.
Thank you. How about Mr. Ueda?
As for Akamatsu-san, thank you very much for your explain about your challenges for the ammonia supply chain. I feel that the very I feel that the new age of starting of the carbon neutral marine fuel stage. So I would like to ask you about the key factor of the such a ammonia expansion as a marine fuel. What is that key factor? What do you think?
Yeah, thank you very much. Okay, so if we talked about ammonia itself, maybe safety is maybe one of the issues. Therefore, if the people have a confidence to use ammonia as a fuel against toxicity, I think that is a key element. But in general, if you talk about a zero emission fuel, including ammonia, I think the key is how end user or society evaluate the value of zero emission shipping. If they compare with like a conventional fuel, of course, we cannot make zero emission shipping. So therefore, I think society or shippers or many industries, if they really need zero emission shipping and evaluate the value of zero emission, I think that is key.
Thank you very much. So that is very important to share the information to the others or for the society about the ammonia. Thank you very much.
Thank you. So I'd like to move to the next topic. Mr. Ueda, I know that the Mitsubishi Heavy Industry Group has many kinds of projects. So could you explain your efforts?
Thank you very much, Matsunaga-san. Then I would like to explain about our activities for the zero emissions. Okay, do you see my slide? Okay.
Okay.
So today I would like to introduce you about the liquefied CO2 carrier and the ammonia as fuel. At first, I explained about the CO2. And the CO2 is a colorless and odorless gas that is slightly heavier than the air at ambient conditions. And if the pressure and temperature of the liquefied CO2 fall to the triple point, dry ice may be generated. And then it may cause the operational problems such as blockage of the piping. To reduce the risk of the dry ice generation during operations, it is generally desirable to transport liquefied CO2 with a pressure kept as high as possible to provide this sufficient margin against the triple point. However, in such cases, the cargo tank needs to be able to withstand a relatively high pressure, and its size will be limited from a structural strength standpoint. In order to keep the CO2 in a low temperature and high pressure state, suitable cargo containment system is applied. The Type C tank is generally adapted for cargo tanks for small liquefied gas carriers. That is well proven. However, in case of the liquid CO2, appropriate consideration against the greater specific gravity is required. That is about the double of the LPG. The Mitsubishi Shipbuilding ensures the reliability of the cargo containment system by conducting the detailed numerical simulation using FEM and CFD calculation. And we conducted comprehensive technical verifications, and our cargo containment system for liquefied CO2 carrier has obtained the AIP from Bureau Veritas. And here is the initiatives of the liquefied CO2 transportation demonstration ship project. And we have signed a contract with Sanyuki Sen, a demonstration ship for liquefied CO2 transportation. And that will be used in research and development of carbon capture and usage and storage technology in Tomakomai by NEDO. The demonstration ship will be delivered in the second half of the fiscal 2023. That is prior to the liquefied CO2 carrier built for the Norwegian Northern Lights project. And so the demonstration ship will be expected to be the world's first liquefied CO2 carrier for CCUS. And Mitsubishi Shipbuilding is responsible for the entire design and construction of the demonstration ship, including the cargo tank system installed thereon. And utilizing our knowledge cultivated so far in the sufficient experience of construction of liquefied gas carriers. And next slide is a CO2 capture system. And we, Mitsubishi Shipbuilding as a MHI groups, and we aim of building the CO2 ecosystem. We are also working on the development of onboard CO2 capture system. In this project, CC Ocean, which was jointly implemented with K-Line and ClassNK and Mitsubishi Shipbuilding, we conducted a demonstration test of a small-scale CO2 capture plant on board and the commercial operating conditions of the ship. This was the first time in the world. The project was conducted over 2 years. A hazard evaluation of the plant and a safety evaluation of the system were conducted. And the demonstration plant was fabricated, installed on the coal carrier, and operated in the offshore environment for approximately 6 months for measurement and checking the performance. And here I would like to move on to the ammonia as fuel. In recent years, including the sense of crisis over the global environmental and climate change, it has been required to take countermeasures for GHG reduction and carbon neutrality. LNG fuel has already been recognized as a bridging solution before carbon neutral fuels. However, it is not so simple. The conditions and backgrounds for the energy supply are different by ship type and operation pattern. And it is expected that the ship's fuel in a variety of segments will not the same and coexist in the segments in the future. As shown in the table left, differently from other candidate fuels, ammonia does not emit CO2, and it has suitable characteristics for mass transportation and long-term navigation. Therefore, the ammonia is recognized as a promising option. And here is our activities for the ammonia. And the Public-Private Fuel Ammonia Production Council under the Ministry of Economy and Trade and the Industry of Japan has set the target of achieving the annual ammonia transportation volume to Japan of about 3 million tons by 2030 and about 30 million tons by 2050. Then we has concluded a technical cooperation agreement with Namla Shipbuilding relating to LPG-powered VLGCs, which are capable of transporting both LPG and ammonia. Based on this agreement, the Namla Shipbuilding is constructing the LPG-powered VLGCs on order from the MOL group. And Mitsubishi Shipbuilding has reached another agreement with MOL and Namura Shipbuilding on joint development of large-sized ammonia carrier fuel by ammonia. This slide shows the comparison between the ammonia supply system package and LNG fuel supply packages. And let's circle area is a similarity between the ammonia fuel supply system package and the LNG fuel supply system package. So LNG FGSS, that is the fuel supply system package, is one of the successful solutions on LNG as fuel. And ammonia fuel supply system will be better to be provided as the same scheme, we think. Preparing for the expansion of general use of ammonia as marine fuel, it is also necessary to quickly set up the ammonia-related rules and training for able crews. LNG and ammonia are same gas fuel. So ammonia fueled ships and equipment and crews skill building based on the same basis as LNG is a better way forward to ammonia fuel. Yeah, one of our prime concern is when the use of carbon neutral fuel will get in a large scale stage. It is difficult to focus the time because there are various elements to be considered. Therefore, to secure the flexibility of the selection in ships operation, ammonia fuel ready LNG fuel ship have emerged as a new option. To manage the ammonia fueled ships, it is also important to secure the capable crews beforehand. Such crew needs to be familiar with handling of the gas fuel. And today, that is well experienced crew in LNG fuel, so that we think that this line from LNG as fuel to ammonia as fuel, we think that is in a straight line from LNG to ammonia. So that is my explanation today. Thank you very much.
Mr. Ueda. Thank you very much. It's almost time. Mr. Motoi, do you have short questions?
Okay. Thank you, Ueda-san. The liquefied CO2 carrier is very interesting. So my question is, to reduce transportation cost, scale up is necessary. So what is the key point to scale up the cargo tank?
Thank you, Motoi-san. I think that the main challenges for the larger tanks is the strength, considering the specific gravity of the liquefied CO2, the thrusting effect and the tank must be sufficient enough. The key to enlargement of the tank is to how to ensure the necessary strength by setting the appropriate operation conditions of the liquid CO2. Yes.
Thank you.
Thank you. Unfortunately, it's almost time. I'd like to express my great appreciation to all the panelists for valuable information today. I think we have heard the latest information towards their emissions. I also believe that today's discussion was useful to the audience as we received information, including specific timelines. Thank you very much for your time today.